Hello and welcome to the physics lab. Today we're going to be building a compound microscope. This allows you to see things that are really small because they get really close to you and they look really big. Okay? They're not really big. They're the same size as they always were. But they look bigger. Alright, so how do we do this? Well, first we need to get all the stuff we're going to use. We're going to need an optical bench, we need some carriers, and we need two lenses. You get the lenses out of these boxes here, and there's ones that say 5 centimeters and 10 centimeters. What do you suppose you'll need? You're going to need two lenses. So what do you suppose you'll need to do? Do you get two of the same or two different ones? Two different ones, not the same one. Get one 5 and one 10. All right? The 5 is what's going to be the objective, and the 10 is going to be the eyepiece. And you put them on the carriers like this. Now you need to have, I didn't realize this had a lens in it. You need to have a lens, one of these carriers here. And you already know how to do this. You push this down, you put your finger in here, and then you let it go, and it hurts like hell. That's what I do with it. But I'm not normal. We already knew that. Okay. What you can do with it is you can put the lens in it so that it looks like this. All right? Now what I've got it set up right now is we're going to measure the focal length for the 5 centimeter lens. And we do this the same way we did it last week in the focal length lab. If we look at the spreadsheet, which is yellow this week, as opposed to the mauve-ish one we've been using, we do it at 3 different lengths for P, 15, 20, and 10. We measure our cues by focusing, moving this till we get a good focus. Focus! Focus! That looks good. Yeah, trust me, it's there. And we get our focal lengths. Now, for the one that says 5 centimeters, you would kind of expect it to have a focal length of, what do you think, Greg?
5.
5! Brilliant. Then we do the same thing for the eyepiece, which is this one here. Take this out, put this one in, do it for the lengths here, the different lengths for the P's, and figure out your focal lengths. For the 10, we don't expect to get 5. We expect to get 10. Let me check. Yeah, 10. Okay. So, now we've got, oh, we're actually almost done. It's really easy now. Here. Now, if you see under here on the spreadsheet and on your lab write-up thing, there's going to be a lab manual. It's going to say useful diagrams and formulas. And if you click on that link, you know what comes up, Greg?
Useful diagrams and formulas?
That's just amazing, isn't it? So let's go to the useful diagrams and formulas, which I already pulled up here. Okay. And this thing here, if you scroll down a little bit, first of all, it has the general setup with formulas, and then it actually has an example. And this is what's going to make your life easy. Because if you look here, you have the distance between the lenses. And you have the distance between the lenses equal to the eyepiece focal length, the objective focal length, plus this distance L. L. What's important about L? Well, L should be a positive number. If it's not, you're not going to be doing very well. Okay? So then you can put in your numbers here, and be very careful. Why? Because the guys who did this are kind of jerks. All right? Why do I say that? Because if you look at some of these things, the quantities are in centimeters, and some are in millimeters. It's the kind of thing I would do if I thought of it. See, the length, the tube length is L. That's in centimeters, and the lenses are in millimeters. Nasty. Okay? Now to figure out the length L, well, that's just the distance between the two lenses minus the two focal lengths. And remember, it's got to be positive. All right. So we fill out that, and it's going to look something like this. Brilliant, isn't it? I feel like I'm in one of those cooking shows where they take the They put the food in the oven and then they take it out immediately and it's all done. You ever feel like that, Greg?
No, this is Mr. Wizard.
Mr. Wizard. Mr. Wizard goes cooking, maybe.
Mr. Wizard does science.
All right. So now, if I look through here, I put my head about, it says about 2.5 centimeters from the lens. And I'm not going to let you see what I see because, you know, you'll have to wait till the lab to get to see that. All right? But trust me, it looks like this, except it's really, really, you know, big. All right? So, what do? You go back over to here. Back over to this spreadsheet. And you fill out L. And you figure out your magnitude of your magnification of your objective and eyepiece. And your total magnification. Where do you get those numbers from? Oh, wait a minute. I already told you if you were listening. It's from the spreadsheet. From the web page. Where that useful links and formulas thing. The formulas are there. You can type in the numbers and get the formulas. The one important thing is to type in the length L. I need that to check your numbers. Alright, and it's even got the formula there to how to solve for L. So you really have no excuse for getting that wrong. Now there's a thing here about ray diagram. A ray diagram. You know anybody named Ray?
Yeah, He's not here.
What's his diagram doing here?
it's not his.
It's not his.
And it's hardly useful.
Yeah, it really isn't that useful, that's for sure. I never found it very useful. And what's interesting too is that link I've just discovered is broken. So it's even less useful than it was before. So what are we going to do? Well, I'm going to look for another link and see if I can come up with one that I like. And if I do, I'll put it in the data sheet. And if I don't, I'll take it out of the data sheet and we'll skip that. Sound like a plan? All right. So then what do you do when you're all done and you figure out the magnification for your compound microscope? Well, you put everything away and you go home. What the hell do you think you do? You're just going to stay around here watching me? Like just staring at me and looking at me? It's kind of creepy, you know? Everybody's always staring at me. I'm at the front of the class and they're looking at me and they're getting closer and closer. And I will see you in the physics lab.